Now we will see what is a work done in an adiabatic process. So again, we will show that in a PV diagram, pressure volume diagram, how the pressure and volume changes in an adiabatic process. We are assuming that this is an ideal gas. So initial state is 1 and 2. So again, this curve is almost similar to the isothermal curve. Again, we will see why it comes like that. Uh, See, because in an adiabatic process, the governing equation is given by PV raised to gamma is equal to constant. This can be derived, but this is out of scope right now. So you can just see that the governing equation is P into V raised to gamma is equal to constant. That also for adiabatic process. So adiabatic process, you know that is a process in which there is no heat exchange. So Q will be 0, and you can see that PV raised to gamma is equal to constant. Adiabatic process. So this is the governing equation. Also, you have the ideal gas equation. PV is equal to MRT, right? So what will be the work done? And you know that Q is equal to delta U plus W, and delta U is equal to mCV T2 minus T1. Okay, that is change in internal energy is equal to, this is the general equation we will use, mCV T2 minus T1, and work is given by, this is the general expression for work, that is integral PdV from 1 to 2. So you know that P1 V1 raised to gamma is equal to P2 V2 raised to gamma is equal to constant. So integral 1 to 2 work is PdV is equal to C by V raised to gamma into dV is equal to integral 1 to 2 C into V raised to minus, C. P is equal to C. You are getting that from this equation. Okay. So P is equal to C by V raised to gamma, and this C is a constant. So if you integrate it, C into V raised to minus gamma, that 1 to 2, you can see that this is equal to C. If you integrate it, you can take C outside. So integral V raised to minus gamma is equal to V raised to 1 minus gamma by 1 minus gamma. Okay. So you can see that here. So this is equal to C into V2 raised to 1 minus gamma minus C into V1 raised to 1 minus gamma by 1 minus gamma. And here this C is equal to, you can write P1 V1 raised to gamma is equal to P2 V2 raised to gamma is equal to C. So here for this C you are substituting P2 V2 raised to gamma. Okay. And here this C substituted as P1 V1 raised to gamma. Okay, we will see why we are using like that. If you multiply this and this, you will get this as P2 V2 minus P1 V1 by 1 minus gamma. This is equal to P1 V1 minus P2 V2 by gamma minus 1. Right? So this is the expression to calculate the work done in an adiabatic process. Okay, for calculating internal energy, mCV T2 minus T1 delta U, and for W it is P1 V1 minus P2 V2 by gamma minus 1, and you know that Q is equal to 0 here. So these are the things to keep in mind in an adiabatic process. So you should know how to calculate the work done in an adiabatic process.